Hello and welcome. My name is Jacob and this is a very short introduction to Clojure.
Next level.
This guide is mostly aimed at people who already know a little bit about programming or a lot about programming and just want to see what this whole Clojure thing is all about. Because Clojure is a great language, but unfortunately sometimes people get a bit weirded out by its syntax. So this is meant as a, very short introduction to a little bit of the syntax and a little bit of the design ideas, design philosophy that went into Clojure. I myself have been using Clojure in Anger for a few years now, so I have some experience with building distributed systems with it. I have some experience building front-end applications with it, and yeah, I just think it's a very nifty language, and I would like to demystify it for you just a little bit so you can get started yourself. So the first thing that we have to talk about are a few characteristics of Clojure. So Clojure is a dynamically typed language, but it is strictly typed. If you're unfamiliar with those terms, don't worry about it too much. But yeah, it might be useful to you if you know what typing is in a programming language. It is meant to run on the JVM. Well, it mostly runs on the JVM. There is Clojure script, which can be transpiled to JavaScript, but we're not going to look into that today. And it is a Lisp, so it is a Lisp processing language, which is where some of the weird syntax comes from. But yeah, it is a functional programming language, and all of its data structures are immutable by default, which is just fantastic once you start wrapping your head around the concept. But yeah, in order to, if you want to just type along this guide or anything, make sure to install Clojure first on your machine, and I'll quickly show you how to do that or where to get it from. So what you want to do is you want to head to clojure.org. You will see hopefully a landing page that looks something like this. And then very simple, you can hop on Get Started here, and there is a little bit of what tools you need and what you can use. There are some other starting resources that are recommended, but what you want to do is you want to hop over here to install Clojure, and then there are instructions for your operating system, most likely for your operating system. So if, like me, you're on a Mac, you just run brew install and then brew upgrade. And yeah, so here are some for Windows, some for POSIX instructions. And it shouldn't take too long. Clojure is not very big, so just go ahead, download it from here, get it installed, and then I'll show you how to execute your first line of Clojure code in the terminal. So once you have launched your terminal of choice, all you normally have to do is type Clojure here, and what this will do is it will start the Clojure REPL for you. REPL stands for read, eval, print, loop. And what this means is it reads a piece of Clojure code, it will evaluate that piece of Clojure code, print any outputs if necessary, and then loop back to the beginning. The REPL is a central concept of Clojure, and you will see that a lot of the development flow revolves around the REPL and trying out bits of code all of the time, which makes for a super fantastic dynamic programming environment where you can just try bits of your code. But we're now here in the Clojure REPL. It tells us which version of Clojure we're running on, and we're currently in the user namespace. Namespaces are a bit like packages in other programming languages. We don't have to worry too much about it. What we want to do is we want to open parentheses, print ln for print line, and then we want to give it a string. And what we're going to print, how could it be anything else, is we want to print line hello world. So you then close the parentheses and you hit enter, and you should get a print line and then the return value nil. This is the standard way to invoke any function in Clojure, and I'm gonna now hop over into the IDE which I have set up. You can type all of this along in the terminal. You don't have to set up an IDE, but it's just a bit easier with the syntax highlighting and everything to show you what is actually going on. Okay, so we're now over here in IntelliJ. And what I have done is I have created the most simple Clojure project just to get it running in the IDE. As I said, doesn't really matter. You can go along and type all of the code that I'm typing here into the REPL running in your terminal. That is perfectly fine. It's just a bit nicer here with syntax highlighting for you to see the differences. So I'm just gonna execute the exactly same command that I did earlier in the REPL in the terminal to like here. And what you can see again, we executed print line hello world. It printed hello world and then returned nil. So in general, you can say that the default syntax semantics for invoking a function is you open parentheses in the first parameter here, in the first position here, you put the function that you want to invoke, and then you give it however many arguments your function needs, and then you close the parentheses. And this becomes an invocation. So we can try this, for example, here with the function plus. So plus is a function in Clojure. We can give it two numbers. We can execute it, and then we get 3 because 1 plus 2 is 3. But because plus is the function we want to invoke, we have to put it in the first position of our invocation, whereas we just said the invocation is every single time there's something within parentheses. So the cool thing is, for example, in Clojure, the plus is implemented with more than just 2 arguments. So you can, for example, say, I want to add 1, 2, and 3, and it will give you 6. However many arguments you can invoke on a function with depends on the function's RET. So every function has a function RET, meaning how many arguments it can take implemented. And Clojure will complain if you try to invoke a function with not the right amount of RETs. So for example, the remainder function we can see here in the preview takes a number and a divisor. Sorry, I'm not quite sure about the terminology, but we can, for example, say we take 100 and we divide it by 10, and the remainder is in that case null. Or if we do it with 9, the remainder is 1, because I can multiply 9 by 11, which gives me 99, and then I have 1 remainder left. So what I can't do here, for example, is I can't give it another number. If I try to do this, I get an exception. It says syntax error RET exception, so that's telling us we have passed the wrong amount of arguments to a function, and it says here wrong number of args, 3 passed to Clojure. So this is telling us that we can't pass 3 to this function. And that's the very basics of invoking functions and nearly invoking anything in Clojure. So what I want to do next is I want to show you how you can define a variable or called symbol in Clojure. To define a variable within a namespace, so we can see here at the top we're in namespace core, which is like a closed collection of functions and symbols. We can just use the def macro. Macros are slightly different from functions. We don't really want to care about the differences right now. You don't even have to remember which ones are functions and which ones are macros right now. All you care about really is you can use def, and then def takes 2 arguments. So the first one is the symbol or the name you want to give your variable, and then the value you want to give it. So for example, 1, 2, 3. And if we execute this here, it's going to tell us within the namespace core, it has now defined a new symbol, x. So this is now in our namespace, and we can now use it. So what we can do is we can print line x, and it will now print line 123 because it's going to look up what the value behind the symbol of x. I'm kind of using symbols and variables interchangeably here, but there's a slight difference. If we do this in Clojure, then what happens is it's not reassigning this value to that symbol, so it's not actually a variable, but it is creating a new entry in our namespace. So the way you can think of it is like a namespace has a big table of all of the symbols and the values, and then it's like looking them up, and in that case it would completely override this entry. So that goes back to this whole idea of everything in Clojure is immutable. You can't change it after the fact. But you can re-declare something. And that's why it's normally called a symbol and not a variable, because technically they're not variable. So we can evaluate this print line, and now it prints 456. That is totally fine. And that's how you define symbols on a namespace level. The other way you can define symbols is in a scoped fashions. So there are multiple ways to go about this. There are multiple scopes you can have variables in like on a function level or in like through macros, etc. But I'm gonna show you like the simplest way or the most or a very common way to define a symbol within a scope, most of the time within functions. But let's take the functions out of the equation. We just want to look at that syntax first. And what you want to do for this is you want to invoke let. So the way you can think about let is let this be that value. So let takes a vector. So this is now something we have not seen before. It's square brackets. And what we want to put in here is, and what the type hinting tells us, it says here bindings. So the bindings mean we can give it pairs of symbols and the values that we can then use within that let block. So we can say, for example, we can say A is the string ABC, and we can say B is, for example, the number 1, 2, 3. And what we can do now is we can print A and print B within this block. So we have this vector here. The vector has A will be this value, B will be that value, and then afterwards, everything after this vector is the body of our let block. We can do whatever we want to do in here. And in this case, we're just print line. We're just printing A and B. And if we invoke this whole expression, you see it prints A, B, C, and 1, 2, 3. And here now comes the difference to the dev. If we try to print line A and B here now, it's going to tell us that it is unable to resolve the symbol A in this context. And this is because a let, or like the symbols within a let, are only available from the opening parentheses to the closing parentheses. So within that block they're available. Outside they're not available anymore. And that's how we can define scoped symbols. So now we want to look at how we can declare new functions, right? Because this is where things actually get more interesting. This is where we can define our own behavior and do more things with the language. So as everything, we start with open parentheses. Now we just need to know what name we need to put here. And what we need to put here is a def n. So it's like a portmanteau of define and fn for function. So we're defining a function. And the first thing we want to give our function is we want to give it a name. So for example, we could call this create greeting. And the next entry that we're going to give is we're going to give it another vector. So we've already seen vectors here where we can say symbol to value. In this case, we only type which parameters the function gets. So let's say our function takes one argument and we're going to name that argument name. And what we want to do next is now everything inside def n here, similar to the let, this is the body of our function. So this is where we can do whatever we need to do in this function. And what we want to do here is we want to greet the name of the person that we pass to. So we're going to use the str function. Str puts two strings together, and we can say here hello, comma, and then the name, and then we're going to add an exclamation mark. And now when we evaluate this, again it's telling us here with this statement that it has created a new symbol, create greeting, in the core namespace, and in that case that symbol points to a function. So we can now invoke this function like all of the functions we've invoked so far. We say create greeting, and then here we give it a name, for example chain, because this is the first, or this is the one argument we need, and we execute this and we get a string returned, hello chain exclamation mark. So what we can try how we did it before, if we invoke this without a parameter without an argument, we get an RET exception, right? It's telling us wrong number of args, 0, pass to create greetings because it only takes 1. So we have to put chain back here. So now you might be wondering, okay, how does this function know to return this string? This is relatively simple in Clojure. So a function in Clojure always returns the value of the last expression in the body. So this means we here have a body, right? The body goes from here until the very end, or like however lines we need from here until the very end. And this is the last expression in the body. So this is what it will return. This means if we put, for example, str hello world here, then this is creating a string hello world, but that's not going to change the behavior of our function in what it returns because it's still only going to return this. Other way around, if we just put this is a test here, then now this string is the last expression in the body. And if we evaluate this function, it's now returning this is a test. So very simple, whatever is in the last position, the last expression in the body, this is the value that will be returned by a Clojure function. Now that we have learned how to define a symbol on namespace level, how to do it locally, how to invoke functions, and how to declare our own functions, we want to look a little bit more about the data types that are actually available to us in Clojure. So just to try this out, we're going to start with a very simple one. We're going to have a, and we've already seen that we can give it numbers like 123. So Clojure supports all kinds of numbers. So if you use a dot, it's a floating point number. It supports hexadecimal, all of those lovely things. And what Clojure does really well is it can very quickly and very nicely convert from one number type to another. So if you multiply a floating point number with, let's just try this out here, with an integer, then it will automatically convert it to the higher scope, to the floating point number. Same with decimals and big decimals. So if you have a really, really big integer and you multiply it by a really, really big integer, in other languages you might have to worry about overflows. Not so much in Clojure. So Clojure automatically promotes to a big decimal and takes care of this for you, which is just really nice. Another type that we have already seen is the string. So everything in double quotes is a string. So we can say this is a string, right? And what I want to do quickly is we can print line the type of certain variables. So we can have a look at this print line type B and print line type C. And if we do this and we execute this, we see the first one A is a long, the next one is a double, and this one is a string. So very straightforward, regular string, nothing too fancy. Of course, we can have booleans, so we can have true and we can have false. So if we try this here, we can see that this is a boolean. There we go, Java-Ling boolean. And then we also have nil. I guess I'm not 100% certain if nil itself is a type. Actually, I've never tried this out. Let's give it a go. I think it's probably going to say type is nil. Yeah, so it basically just says nil is nil. And it's Java's version of sometimes what is called null in other languages, so the absence of a value. And I guess one of the last ones that you might encounter a little bit more often is a single character. So a single character, like the uppercase character C, is denoted with a prefixed backslash. And what we can do is we can again here print its type, and you will see that it's a Java-Lang character. And those are kind of like our most simple data types. But now we're going to get into the more exciting ones, which are the collection types. When you're working in Clojure, you will mostly encounter two types of collections and sometimes a third one, of course, there are many, many more. But if you know vectors and maps, you are doing very, very well. So let's start with another let block. And what I want to define is I want to define a vector. And what we're using here is we're using square brackets. And what we can put in a vector is we can put any amount of values that are gonna go into a sequential collection. So this, a vector, is a sequential collection, a vector, of the entries 1, 2, 3, 4, 5, 6, 7, and 8. It is, of course, always recommended to keep the same types of things in a collection, but technically it is not necessary. And now we can do with that print line whatever we would do with collections in other languages. So here we can, for example, say this is a persistent vector. The persistent we can safely ignore for now, but we know it is a vector, which is very similar to what most other languages would call a list, but there are some slight differences to actual lists in Clojure here. So we're going to keep calling this a vector, which is what it is officially called. Another thing that we can do is we can just print line a vector, right? And it's going to give us all of the entries. We can also, for example, print line only the first item of a vector, which is only going to give us 1. Or, for example, second, which is also a nifty function that you sometimes need, which is only going to give us the second item from the collection. Or, for example, the rest, which would be everything but the first item, so everything from 2 to 7 here, and anything you can do with collections. So this is the very basic sequential collection. And the next one where I said you're mostly going to encounter 2 is a map. So a map is a key value collection, and it looks like this. So this one uses curly parentheses. It's going to need a key, and then it's going to, for example, store 1, 2, 3 in this key. It can also have as many key value pairs as you want, so this could be another key with the value 4, 5, 6. And now we can print line again the type. If you want to see this, a map, it's going to say this is a persistent array map. And what we can also print line is we can print line first of all, the whole map. So we can say print me the whole map, which is lovely. It's going to give you a key, 1, 2, 3, another key, 4, 5, 6. And what you might notice here is it printed a comma. So in Clojure, you can put commas between your key value pairs. You can also put commas between items within a vector, but you don't have to. So the Clojure interpreter treats commas as white spaces, basically as if they wouldn't exist. And therefore they are optional, and you will very, very, very often see Clojure developers not use them. But if you want to, hey, it's up to you, go for it. So we saw again here that it printed the whole map. And now what we can do is we can use the function get to get from our a map with a key, that value within that key. And for example here, it's going to return 1, 2, 3, right? Because this is the value that is stored with that key in the map. Or we can use another key here, and it's going to say 4, 5, 6. Or if we just say foo key, which is not a key with which we have stored anything in the map, it's going to return nil. So one very important design decision in Clojure is in that it doesn't blow up easily, it doesn't throw exceptions easily. It very, very often return nil if it can't do something. So in other languages, if you're used to other programming languages, getting an item from a collection with a key that doesn't exist might throw a specific exception, say, hey, you can't do this, I haven't found it. In Clojure, it will just return nil. And the idea is something called nil punning, and it often makes it easier to connect calls with each other because everything works relatively well with nil. If something can't get an item in like a chain of calls, then it's just going to keep passing nil until you have nil at the end, and it's not just going to make you deal with exception handling in the middle. Of course, the downside to this is that sometimes you end up with nil somewhere and you don't know where it started, so you have to go and investigate where your initial nil came from. So pros and cons, but that's just how Clojure does it. And now you know the very basics of how to use a map. Now, using strings, for example, here as keys, or you could also use numbers, characters, you can use anything as a key, is pretty nifty, right? Like this isn't too bad, but Clojure has a concept that is gonna make this even better, and that's keywords. In Clojure, a keyword is any symbol that starts with a colon, so this is a keyword here. And what keywords effectively are is they reference back to themselves. So they're kind of like, well, they're keywords, right? They key a specific concept within your program. And if this sounds a bit too abstract, I'm going to show you now how you can use them. So let's say we have a let here and we want to define a person. Then what we can say is we can say a person has a name, right? So we can use our classic, well, if I can type, we can use our classic string here. We can say we have a name, and that name, for example, is Jane Doe, right? And then within our let block, we can say get person name, and this will work. It's going to give us Jane Doe, right? But what we can use instead of this string as a key here is we can use, let's say John. We can use the keywords here as our keys. So we can say colon name is John Doe. You can still use the keyword exactly the same way we have used the string here. So we can do get John and then keyword name, and it's going to tell us John Doe. But keywords are special because what keywords do is they implement the function interface. So what this means is we can actually put, well, let me keep this as a reference. We can actually put name here in our first position, which will make Clojure treat this like a function. And when we do this, it's again going to give us John Doe. So keywords themselves can be used as functions, which is really, really cool. It makes looking up things from maps a little bit terser, a little bit simpler, and it reads a bit nicer, right? Because here you say get John name, but here you can say give me the name of John, right? And that's kind of like how people normally talk about this. I need the date of birth of John. I need the name of John. I need the address of John, right? And so this lends itself very nicely to thinking about it this way. So yeah, and now you know how to use keywords, and the preference is normally to use keywords. So you will see them everywhere in Clojure code. So now if we can make some decisions about like branching in our code, then you can basically go and write most programs. So the most basic control flow construct is of course the if, right? So if normally works that way. So you say, let me put a comment here. If something is the case, then do this, else do this other thing, right? And in Clojure, that's basically exactly what it looks like. So you say if, and of course you need to wrap it in parentheses, then a predicate expression, then a then expression, and then an else expression. And that's exactly how an if works. So let's say we want to print if a number is smaller or bigger than 10, right? So we can let x be 5. And here what we're going to do is we're going to say if. And now we're going to compare it. So if smaller x than 10, then we're going to print line x is smaller than 10. And else we're going to print line x is greater or equal . And if I could type, that would be fantastic. So, and if we execute this, right, it is telling us x is smaller than 10. If we analyze this, we can see this is our predicate expression. Then the next one is our then expression. So if this returns a truthy value, we're going to execute this branch. And if this returns a falsy value, we're going to execute the else branch, right? In this case would be else is greater than or equal to 10. So if we pump this to 14, right, and execute it again, it's going to go over here. X smaller than 10 is going to return false. Therefore, we execute the else branch and it's printing, it's printing X is greater or equal to 10. And that's how you make basic decisions. All right, you're nearly there. You have learned a lot of the base concepts of Clojure. Now let's put it all together in one last example, a small example that's going to use all of the concepts that we have just learned. And in that case, we say we're going to have a vector of people where every person has a name and an age. And what we want to do is we want to greet every person according to their age, where we say every person that is above 30 years old should be greeted a little bit more formally than any other person. So let's start here with saying we're going to define a list people and we're going to put in 2 entries. So the first one we're going to say is name John, and we're going to make John 45 years old. And then we're going to have a second person here with the name Jane. And we're going to make Jane, well, what do we make Jane? Let's say Jane is 28 years old. So you can see we have one map here, John age 45, and one map here, Jane age 28. And we put them into a single vector. So we have 2 entries in our people vector. And we can verify that by saying what is the count of people. And it's going to tell us 2. So we have 2 people in our list of people. All right, now let's think about our greeting function. So we need to define a function greet person, which is going to get a single person passed. So we need to make a decision. If the age of the person is above 30, we should create a more formal greeting. So we need to make a decision based on the age. So in order to make a decision, right, we said we need an if. And if you remember, the first expression in if is the predicate expression. So we need to say if the age of the person is above 30. So where do we get the age from, right? The age is in person, and we know that we can use keywords as functions to get something from the person. So we can just say, give me the age of person. So now that we say if the age of the person is above 30, we need to create a formal greeting. So we can say, good evening, and then the name of the person. So in order to get the name of the person, we do exactly what we have done with age here, and we're gonna say, give me name of person. All that is left now to do is, what if they are 30 or below? We need a less formal greeting, so we can say, what is less formal? Hello! And now again, the name of the person. Right, so to quickly recap, we pass a person, which is a map, to greet person. We get the age and check if age is bigger than 30. If that is case, we get the name from the person and append it to good evening. Otherwise, we get the name of the person and append it to hello. What we could have done here is we have a little bit of duplication. We could have used the let block to say name is name of person, right? And then put all of this into the let block and then reuse name here. Right, so a little bit less duplication, but we have this extra block here. You can do whatever you prefer. We're gonna evaluate this and we're gonna quickly try it out by calling greetPerson with the first of people. So this is gonna pass John to greetPerson and hopefully it's gonna say good evening John, which it does. Now let's try sending the second one in. And it should pass Jane. And it says hello Jane. Lovely. Now all we want to do is we want to do this for all of them. So we are going to use a for construct. This is new. We haven't done this earlier. But what for is like similar to a let, that it takes a key, a pair of a name and a value, but it's doing something a little bit different. So this is saying for person in people. And if we try this out and print the person, what this effectively is going to do is for every single person that is in a collection here, people, it's going to print line the person. So you see here it prints first John and then it prints Jane. But we don't want to print the person, is right? We want to print the greeting. So we're going to say greet person of person and execute this. And we get our two greetings. We get good evening John, because John is the first person in the list, and then hello Jane, because Jane is the second person in the list. And this is it. You have now learned the very basics of Clojure. You know how to define variables, you know how to define functions, what maps and vectors are. You can make some basic decisions with if, and you've also already learned how to, for example, iterate over a collection of people and do something for all of them. Okay, you did it. This was a very short introduction to Clojure. If you understand the concepts presented in this video, you can probably go and read about 90% of Clojure code written. Like, the syntax is so uniform. That is what's so lovely about Clojure. Like, it's always open parentheses, the function, and then the arguments. Like, it's just great. I'm gonna link a few resources that I personally really enjoyed when I was learning Clojure that you can go on and read about. I can also really recommend checking out the Clojurians Slack group or Slack channel. Well, I guess it's just a Slack space. I don't know what they call it, to be honest. But check out the Clojurian Slack. There are so many lovely people there. There's a dedicated beginners channel where people ask for help and receive help all the time. It's a very welcoming place. And yeah, I hope you enjoyed this. I hope you give Clojure a go. As I said, like, I really like this language and it really changed how I think about programming. And I hope to see you next time. Bye bye.